Let's see. I'm going to go live until probably just before 5, I think. Where am I streaming from? What do you mean? My home or my city? I'm in Cape Town in South Africa. All right, guys. I posted a post on my Instagram a few days ago where I said that I was going to go live today, and I also asked what you guys would prefer for me to do. The topic I asked, would you rather do functions or Euclidean, and functions was the topic that won. Zunaid, yes, most of my videos are on YouTube. My YouTube content is more like explanation stuff, where my TikTok is some explanation stuff, but then also like, yeah, more short form content. But I have longer explanation videos on my YouTube. All right, so for this one here, it says consider the function drawn below and answer the questions which follow. Now, what is interesting about this question, and I just got this from a colleague, I'm not actually sure where it came from. It's not like a past paper, but I just think it's a really nice question to look at. So they haven't given us the equation of this graph, right? They just are giving us the picture. And what is interesting here is that they have given us the coordinates of the two turning points. So we have one turning point there, we have the other turning point down here, and then they've also given us the coordinates of the point of inflection over there. The question that they're asking us, or the questions, they're saying we need to use the graph of f to determine the values or values of x for which the first question is saying concave down. Now, I'm just going to write little notes as I go, just in case there are some of these things that you don't know yet. So a graph is concave down when it looks like, well, let me actually just write here where f dash dash x, so the second derivative of f, is negative. So if they've given you the equation of the graph and they're asking you where is this graph concave down, you can find the second derivative and make that smaller than 0 and then solve for x. In this case, they haven't given us the graph, the function. They haven't given us the actual equation of the graph, but we can look at the graph. Now, concave down has to do with the point of inflection. So I'm also going to just write that there, point of inflection. On the one side of the point of inflection, our graph is concave up, and on the other side, the graph is concave down. Now, concave up is like a cup, and concave down is almost like a downwards facing parabola. So what we have here, we have the point of inflection over there, and then this section of the graph is concave down. Sorry, that's a bit shaky, but you guys get the idea, right? So this section of the graph is concave down. If they had asked us for concave up, like a cup, you see this section on the right of the point of inflection. Concave down is on the left of the point of inflection. Now we need to write our answer in terms of x. So we need to look at the x coordinate of that point of inflection, and we need to say which x values do I have on the left of the value negative 0.2, and that is going to be all values that are smaller than negative 0.2, right? If we're looking at this, we have an x value of negative 1, an x value of negative 1.3, negative 2. All of these x values here are smaller than this x value of this point, of the point of inflection. So that is what we're going to write down as our answer, x smaller than negative 0.2. Right, let me just quickly erase that there. So our answer for that question, x smaller than negative 0.2. That is also just a 1 mark question. In a test or exam, it usually is 2 marks. So in like your final paper, these questions usually count 2. They will give 1 mark for the value and 1 mark for the smaller than, right? So you can expect to get 2 marks for a question like this. The next question, where f is increasing. Now, an increasing graph is where the y values are increasing, right? So basically where your graph is kind of moving up as your x values are getting bigger. So as you are moving to the right on this graph, you are also going to look at where are the y values going up. Oh, Eskom is here. Great. All right, so increasing. That section is increasing, right? I'm sure you guys agree with that. Our y values are getting bigger. If we had to look at a y value here, it's negative, right? Then it's going bigger and bigger. Here we have a y value of 3.7. It's increasing for this section. At the turning point, your graph is neither increasing nor decreasing. It's like a constant value there. It's constant. After the turning point for this section, we can see that the graph is decreasing. All right. That's not what they're asking for. They're asking for increasing. At the turning point, again, it changes from being decreasing to increasing. So now, again, for that section there, the graph is going to be increasing. And guys, something that they've left out on this graph is the arrow, right? We know that we actually have arrows. Oops, that's not a very good arrow. We actually have arrows on either end of this. All right, so we are going to say where x is smaller than negative 1.3 because it's all x values on the left hand side, right? So where x is smaller than negative 1.3, or we have to say or if it's two separate parts. So it's a part here and another section there, we have to say or where x is greater than 1 because all of the x values here on the right hand side will be greater than 1. All right, so that is what we're going to say. X smaller than negative 1, 3 or x greater than 1. So let's write that down. X smaller negative 1, 3 or x greater than 1. This will be a 2-mark question as well. They will give 1 mark for the values and 1 mark for the symbols. So ma'am, is there a question where we have to calculate the point of inflection if it's not given to us? Yes, we will do one of those. I am not going to be doing trig today, but I definitely will do it in future. Lots of people have requested trig. Okay, now I hope you guys are fine with these 2 questions. We're now going to move on to one that is quite a bit more complicated. We are asked here to find values of x for which f of x times f dash x is less than 0. So what I'm going to just write here is, remember that f of x, that actually represents y values, right? That's when you learn about function notation about f of x, we tell you that f of x just replaces your y values. Now guys, if your y values are positive, that means that the graph is above the x-axis. Right? Where do you have positive y values? Remember that your Cartesian plane, oops, that's not a good picture. Your Cartesian plane, it's basically 2 number lines that intersect. Let me move that up a bit. So here on the y-axis, and there we have our x-axis, so this is y, that's x, here we have 0, right? The part of the y-axis that is above the x-axis, so this part over here, these points over here, if we had points, would all have positive y values. Oh, sorry. If we have negative y values, where will those negative y values be? Below the x-axis. All right, so that's where I'm getting my above the x-axis and below the x-axis from. So when they're talking about f of x, we need to consider that. F of x represents all the y values. Now, they're saying that we need to multiply the y values by f dash x, which is the derivative, right, of this graph. Now, guys, the derivative of a graph is the same as the gradient. So if they're talking about f dash x, yes, they're talking about the derivative, absolutely, but they are also talking about the gradient of that graph. Now, if your gradient is positive, you learned this in grade 9, a positive gradient is an increasing gradient. An increasing graph has a positive gradient. A negative gradient, if you have a line that has a negative gradient, if you'll remember that, that is a decreasing line. But it goes for all functions. If the gradient at a specific point is positive, then it is increasing at that point. If the gradient at a specific point is negative, it's decreasing at that point. So we need to consider both y values of this graph, but also whether the graph is increasing or decreasing, right? Now guys, the key to this question is obviously understanding what I've just explained, but also what are they asking for? They're asking for less than 0. What does less than 0 mean? It means negative. Just seeing where I can fit this in. Now guys, for the product of two things, because we do have two things, right? F of x and f dash x. If we have two things, the product of two things, for that product to be negative, we have to have a positive multiplied by a negative. You learn this in grade 8. A positive times a negative is a negative answer. So this product, for the product to be negative, we either need to have a positive y value coupled with a decreasing graph, or we need to have negative y value, so a graph below the x-axis, coupled with an increasing graph. So that's what we're going to look for, guys. We're going to look for the following combinations. We're going to look for a graph that is above the x-axis, because then f of x is positive, and at the same time, that graph has to be decreasing, because that will be a negative derivative. If you have a positive y value multiplied by a negative derivative, that answer will be negative. Positive times negative is negative. Or we are going to look for a negative y value or negative y value. So a graph that lies below the x-axis and at the same time, this is negative, right? So if the f of x values, the y values are negative, then the gradient, the derivative, let me actually move it across and I'll just zoom out a little bit. The gradient has to be positive, so the graph has to be increasing. Right, so those are the combinations that we're looking for. Let's quickly see on the graph, can we find a place, and I'm going to use my highlighter and I'm going to highlight those sections. Can we find a place where the graph is both above the x-axis and decreasing at the same time? Right, so let's go from left to right. Here the graph is below the x-axis. I'm not looking for that. Here the graph is above the x-axis, but it's also increasing, right? If it's above the x-axis, y is positive. If it's increasing, the gradient is also positive. So that is positive. If you multiply those two together, that's not going to work. Guys, what about this part here? If I'm looking at this part, here the graph is above the x-axis, so I have positive y values, right? F of x is positive, but the graph is decreasing, it's moving down, so the derivative is negative. If you multiply a positive and a negative together, what do you get? You get a negative answer. So I'm going to have to write this section as a part of my answer. Now, which x values am I looking at here, guys? I'm going from negative 1,3 to, I think that's negative 0.5. All right, so I'm going to say from negative 1,3 to negative 0.5. I'm writing or so long because I know that there is going to be another section, but that is one section where the graph is above the x-axis and it's decreasing. Let's see if that happens again. Well, there's only one more place where this graph is above the x-axis and it's also increasing here. So that's not going to work, all right? Because positive y values, positive gradient. If I multiply those two together, the answer is positive. Let's look at the other combination that I'm looking for here. I'm looking for where the graph is below the x-axis. That is where y is negative, and where it's increasing. So that's where the gradient is positive. So let's see if we have that. I'm going to use pink. Below the x-axis and increasing. There we have it, that first bit, right there. Here the graph is below the x-axis, so that means that our y values are negative. But the graph is also increasing, so that means that f dash x, the derivative, the gradient is positive. So that's going to work. So how am I going to write that? That is from where x is smaller than negative 2. All right, so let's add that. I'm actually going to write it in pink. Where x is smaller than negative 2. Let's see if there's any other place here where the graph is below the x-axis and it is increasing. Below the x-axis and increasing. Between 1 and 2, right? For this section there as well. The graph is below the x-axis and the graph is increasing, so the gradient is positive. So I'm going to write between 1 and 2. Okay, so let me just quickly write that down. Or between 1 and 2. Another way in which you could write this, because a lot of people don't like this notation, you could also write it in, what's it called? In interval notation. Sorry, this is inequality notation. It's getting to that part of the day now where I forget my words. This is in inequality notation. We can also write it in interval notation. So guys, this is actually the smallest values, right? This is actually the first interval. So I'm going to write this one first. So I'm going to say x is an element of, now if it has to be smaller than -2, if it's going from -2 and it's going all the way to the left, remember there's supposed to be an arrow here. It's actually going to go to negative infinity, right? Because it's continuing on in that direction. So we're going to say from negative infinity to -2, right? That is that section. Or from -1,3 to -0.5. Or between 1 and 2. So from 1 to 2, you can say 1, 2, 2, like that. I think a lot of people actually prefer this way of writing it. I think it is easier to write it in this way. A square bracket for 2? No, not now, because they were asking for just negative, not equal to 0. Okay, so if there was a line here under your smaller than symbol, then yes, you would have square brackets. Then you would have a square bracket for 2, and you also would have a square bracket for -2 and for -0.5. All of the places where your y value is actually equal to 0. Okay, but because they didn't say negative, smaller than or equal to 0, all of them have round brackets. All right, but that's a good question. Thank you. So guys, this is definitely a higher order question. These questions where they're asking you to find places where the product is negative or positive, right? So they've said where the product is negative. So we're looking for where the one value is positive and the other one is negative. Yeah, I am explaining it again. So because the product has to be negative, we're looking for places where f of x is positive and f dash x is negative, because a positive times a negative gives you a negative answer. Or we're looking for places where f of x is negative and f dash x is positive, because that will also give you a negative answer. All right, so what I went through here, everything that I wrote down, I'm explaining what f of x represents. It represents all the y values. The y values are positive when the graph is above the x-axis, because it's on this place, and the y values are negative when it's below the x-axis, because all of these points, if you had points over here, they would all be negative. The derivative has to do with the gradient of the line, so, or the curve rather, not the line in this case, apologies. If the gradient is positive, that is an increasing line or an increasing graph, right? You learn in grade 9 that a positive gradient looks like that. If it's decreasing, then the direction has to look like that. So now, because we're looking for a positive and a negative, we're looking for a combination of, let's use highlighters here, we're looking for these two together. Because if you multiply a positive y value, f of x, with a negative gradient, f dash x, your answer will be negative, right? That's the green. If you are taking, which color can I use? Let's use purple. If you are multiplying these two together, negative y values and positive gradient, negative times a positive is a negative again. So that's what we were looking for on the graph. We were looking for places on the graph where these combinations are happening. All right. Take a second just to kind of digest that. I'm quickly going to erase my notes here so that we can look at the next one. These questions are difficult, so don't panic if you're not fully understanding it yet. You might have to look at this again, maybe one or two times. See, someone is saying, oh, good. That's a good reaction always. All right, let's quickly look at the last question. The last question is similar, but for the last question, they are saying now that we need a product of two things to be positive. Now, before we look at what they're asking us about, let's quickly just make a note about this. And this time it's positive or equal to 0. So this time we are going to include our values. That would make the product equal to 0 as well. In the previous question, there was no little line there. I put that blue line in there. Maybe I should just go erase that. I don't want people to get confused with this. This was just a hypothetical someone was asking me. Okay, the question actually didn't have that in originally. In this case, the question does have it in. All right, so this is saying positive or equal to 0. Now guys, for you to get a positive answer when you are multiplying two things together, you either have to multiply two positives or two negatives, right? A positive times a positive is positive, and then we also know that a negative multiplied by a negative is also positive. For a product of two things to be equal to 0, you need to either have a positive times 0, or you need to have 0 times a positive, or a negative times 0, or 0 times a negative. Basically, we know that anything multiplied by 0 is 0. Okay, so we need to just think of that. All right, now let's think about what they're asking us about here. Again, we have f dash x, right? Which is the derivative, which again is the gradient. So I am just actually going to make an arrow here. I'm not going to rewrite all of that. We need to think of this first part of the product is or has to do with the gradient. So is it positive? Is it increasing? Or is it negative? Is it decreasing? The second part here, f dash dash, the second derivative, this is concavity. This has to do with whether it's concave up or concave down. Guys, if your graph or if your concavity, if your second derivative is positive, that means that your graph is concave up. So it almost looks like an upwards facing parabola, right? That is concave up. That's the kind of shape that we're looking for. If your second derivative is negative, that means that the function is concave down. So it looks like a downwards facing parabola. That is the kind of shape that we're looking for there. All right, so we are again going to look at where is the graph increasing or decreasing, and at the same time, where is it concave up or concave down. Now guys, our product has to be positive. So we are going to look for where the graph is increasing. That's where our f dash x is positive, right? That's positive. And where is it concave up? Because that is where the second derivative is positive. Why am I now doing positive and positive? Because the question is asking for positive. Right? A positive multiplied by a positive is equal to a positive answer. Let's quickly look at the graph to see if we can find anywhere where this is happening, where the graph is increasing and it's concave up. All right, now just get my highlighter here. This is an increasing graph, right? The graph is increasing for this section over here. But guys, for this section also, we can see that we have that shape of a downwards facing parabola, right? So this is actually concave down, this section here. This section here, the whole section there is concave down, all right? And this is increasing, that's not going to work. Now let's see here. This is concave up. And remember, what are we looking for? I'm going to go back down. We're looking for increasing and concave up. Okay, increasing is here. Is it concave up? No. So that's not going to work. Where else is this graph increasing? Here. Oops, sorry, that doesn't look good. It's increasing here. Is the graph concave up here? Yes. Okay, so this is increasing. And it is concave up. Positive gradient, positive concavity, the answer is positive. All right, so I'm going to have to write that down as part of my answer. I'm not going to write it down yet. I'm just highlighting for now. Okay, next up, so we found positive and positive. Guys, am I now going to include where the product is negative or is equal to 0 rather? I'm going to include where the product is equal to 0. Okay, so now the product, if we're thinking of f dash x, where's f dash x equal to 0? Let me write this here. I hope that you guys remember that in order to find the turning points of the graph, f dash x would be equal to 0. So guys, I actually have to include the turning point here of the graph, right? That 1 is going to have to be included in my answer. I have another turning point also here, right? The derivative is equal to 0 there as well. So I'm going to have to add that as well. Okay, we must just make sure whatever other values we have in our answer, we have to include the turning points as well. Okay, let's quickly take a look. We've done positive and positive. We still have to do negative and negative, right? Because that will also give us a positive answer. So negative is going to be decreasing, because that is a negative f dash x, and concave down, that is a negative second derivative. Decreasing, negative gradient, concave down, negative second derivative. Negative times a negative is a positive. Okay, so let's take a look. Let's look on the graph. It's probably easiest to first just find where the graph is decreasing and then also check, is it concave down? All right, so let's take a look. The graph is decreasing here. This whole section, right? I'm going to highlight that whole, sorry about that. You get the idea. The graph is decreasing for that whole section, but is it concave down for the whole section, guys? It's actually only concave down for that part. See if you agree with that. Concave down is from this turning point here. Well, this whole section actually is concave down, but decreasing and concave down is this part there. Sorry about that highlighted bit. Turning it into a straight line. Let's try and just make it a bit clearer. There we go. Right? Okay, so our answer is going to be, and now I know it's difficult to even get the sections. Now you must still write it down as well. Okay, but this is going to be between negative 1.3 and negative 0.2. That was the x value of the point of inflection, right? I'm looking at that there. This minus 2 is confusing. Okay, that minus 2 doesn't actually have anything to do with that point. I'm going to say negative 1.3 to negative 0.2. That's that section. And then this section is going to be, actually, look, I almost made a mistake. I have to include that turning point. Why? Because it has to be equal to 0 as well. Equal to 0. All right, that's why I am including the turning point, because at the turning point, the derivative is equal to 0. So I have to include it. For this section here, I'm going to say 1, and I'm going to do this. So this is one way in which you could write it, or you can also write just x is greater than or equal to 1. Remember, we are supposed to have an arrow there. Okay. I also have videos on my account, on my YouTube, about probability, just letting you guys know. Since you are here, you can just as well go look at my YouTube. All right, so those are the two sections that we need to put on our in our answer. You can decide if you want to write it like this with the infinity or like this, right? So those are the two parts that we're going to put in our answer. Let me quickly just write it down at the bottom, and then I'll also show you the different way in which you can write it in interval notation. What do you guys prefer? Do you prefer inequality notation or interval notation? Let me know. I always feel like people prefer interval notation. Yes, interval notation. Okay, let me quickly rewrite this in interval notation. You still get full marks for interval notation. Don't think that it's not as good of a notation. You will get full marks for it. So we're going to say x is an element of, now because the turning point is included, we have to do a square bracket. So we're going to say 1, 3, semicolon, negative 0.2. That one is excluded. Actually, wait, what was 0, 2? Oh, guys, the point of inflection I also have to include. Remember what happens at the point of inflection? The second derivative is equal to 0. That is so important, guys. It's good that we've picked up on that now. That also needs to be included, okay? Because at the point of inflection, remember, if you are asked to find the coordinates of the point of inflection, what do? You make the second derivative equal to 0, all right? So for this, if you have any number multiplied by 0, you will also get an answer that's equal to 0. So please add that. Okay, that is very important. We almost missed that. Let me add that to this answer over here. And then that means that this bracket must also be a square bracket. Right, you really have to think hard with these questions. It really is complicated. And then for this one, we're going to say from 1 to infinity. Guys, with infinity, you always use a round bracket because infinity is not actually a number. Remember, we only use square brackets when the answer can be equal to that number. Then we'll use a square bracket to show that it's included. But if it's infinity, you can never actually have something equal to infinity. So you will always use a round bracket there. Okay, I do want to just give you one piece of maybe good news. They will never test, or they'll never give you 2 of these questions in an exam because it's testing the same concept twice, right? So they might give you this question, but then they won't give you another product question because their thinking is if you don't know how to do the first question, you're also not going to know how to do the next one. All right, so they won't give you 2 questions that are testing exactly the same concept. You might get 1 of these. All right, hope that's fine, guys. Let's look at, I think what I'll do is I'll post this page on my Google Drive. So if you have not been to my Google Drive, you can go onto my Instagram. The link is there in my bio. The one link in my bio is to the cheat sheet, the grade 12 cheat sheet. And then the other link is to my Linktree, which just has links to all my resources and my YouTube channel and all sorts of things. So you can go take a look there. Oh, I see one of my... Thank you, Taz. Hello. How are you doing? My YouTube name is Miss Honeycomb. So the same as my name on here. Alright guys, let's look at a hyperbola question quickly. So this is from last year's exam. I always say that there are 3 types of functions questions that they always ask. The one question is always about hyperbolas. I don't know why they always test hyperbolas specifically. There's always, hello Kewan. All my kids are coming now. It's nice to see you guys here. All right, yeah, the first question is always a hyperbola question. So I think some people neglect it because they think it's either very easy or they're not going to ask it, but they definitely always ask it. All right, so let's quickly look at this question 4. Again, it's from November 2022, so it's last year's exam. And I'm just going to go over this very quickly. Guys, for hyperbolas, there's a lot of theory that you need to know. You need to know the standard form, you need to know the asymptotes, you need to know where everything is coming from, right? You can't just look at it and say, oh, I know how a hyperbola works. You actually have to spend some time on it. Safia, this is grade 12. Okay, so for question 4, they have told us here that they have given us the graph of h of x, which is 1 over x plus p plus q. Guys, this is another thing. I usually put a minus there, right? When I write the standard form myself, I'll always say a over x minus p plus q, and obviously that's equal to y. But it doesn't have to be that way. They can change the sign like they did in this question. Please don't be thrown off by that. It just still works in the same way. Your equation is just going to, your standard form just looks a little bit different. Taz. Oh dear. All right, so what was I saying? Yes, so they've given us an x plus p here, but we are still going to find the equation in the exact same way. All right, so please don't think, oh no, I don't know what to do. I've only ever seen x minus p. It's the exact same thing. You're going to do the work in the same way. Now this is interesting what they've done here. They're telling us that the asymptotes of h intersect at 1, 2. So they're not giving us the equations of the asymptotes. They're telling us that these two asymptotes, so this point here is the point 1, 2. But guys, if you look at the graph, they're actually telling us there that this is a 1. This is an asymptote with an equation of x equals 1. This is an equation, an asymptote with an equation of, look at that, y equals 2. But guys, even if they didn't give us those two values there, if they just give you the point where these two asymptotes intersect, the x asymptote is the x value of that point, right? Look at that. The y asymptote is the y value of that point, because this point is an x value on the x asymptote. I don't know how else to explain it. I hope that this is making sense. This point 1, 2, the y value of this point is 2. Every single point on this line is going to have a y value of 2. That's why it's called y equals 2. All right, now they haven't actually asked us for the equations of the asymptotes, but look at what they're asking us for here. 4.1.1. Write down the values of P and Q. Guys, the values of P and Q, we are going to use our asymptote equations for those values. Right? We know that. Now, what I want to suggest, before you write down the values of P and Q, because they've changed the sign here, they've thrown us for a loop a little bit. Actually, first write down the equation. Right, so the equation is going to be y equals, that's nice of them, they've given us the a value, right? They're saying 1 over, now we know that if the x value is positive 1, the x asymptote is positive 1, we have to have x minus 1 in our equation, guys. That denominator in this equation, the sign in front of that number, is always the opposite sign to what we actually have in the asymptote. For the y value has the same sign, right? So if it's y equals 2, we're going to put a plus 2. If it was y equals negative 2, we would put a minus 2. All right, the x asymptote is the one that has a different sign to what is in the equation. Now, guys, if you've written this down, the actual equation first, then you can look at what they've given us here. X plus p is x minus 1. So what is p then? P has to be negative 1. The q value plus q is plus 2, so q has to be positive 2. Right, 2 marks. 1, 2. There we go. Right, next up, calculate the coordinates of the x-intercept of h. Now, guys, we need to use this equation that we wrote in the previous question. All right, if we're not, that's the only way that we can. Because remember, how do you find the x-intercept of any graph? You make y equal to 0. So in this equation, I'm going to make y equal to 0. Okay, I'm going to just write it over here. So for 4.1.2, we have y equal to 1 over x minus 1 plus 2. And now for the x-intercept, you have to make y equal to 0. So 0 is equal to 1 over x minus 1 plus 2. And now we need to solve for x. Guys, you always get the first mark for that, right? This is a question out of 2. Your first mark will be just for showing that you know that to get the x-intercept, you must make y equal to 0. Now we must solve for x. I'm going to move that 2 over to the other side. Negative 2 is equal to 1 over x minus 2. Now I'm going to multiply by I said x minus 2. It's x minus 1, right? I'm going to multiply the other side by that. So I'm going to have negative 2 times x minus 1 is equal to, what's left over here when I move that x minus 1? 1. Now you can decide, do you want to multiply the negative 2 into the bracket, or do you actually want to get rid of the negative 2 first? That will actually be faster. So if you say on this side I have a 1, now I must divide by negative 2. So I have x minus 1 equals negative a half, right? So I've just moved that negative 2 over to that side, and now you must add 1. So x is going to be equal to negative a half plus 1 is positive a half. All right, that is the x-intercept. We can see there. It makes sense that it should be a half, right? Because that's x equals 1. So this is going to be the point 1, 0. Okay, great. Next up, so that's the answer to 4.1.2. And guys, there's quite a lot of working that you have to do here. Your second mark is only for the answer. Okay, so you don't have to show every single step. If you want to do some of that working in your head, if you feel like you are able to, then feel free. But just make sure that you're not making a mistake. Okay, next question. This is an interesting one. Write down the x-coordinate of the x-intercept. Right, so we have the x-intercept here, x-coordinate and y-coordinate. They're only now asking for the x-coordinate of the x-intercept of g if g of x is equal to h of x plus 3. Now guys, we need to think, what does that mean? If I have an x plus 3, right, what's happening to, well, h of x is this graph that we have over here. All right, let me actually rewrite this equation with an h of x here. Now, if we have h of x plus 3, that means, and that's the graph of g, right? That means that we actually need to now, we need to now think of what is actually happening to the x values that we have there. Now, the x, why did I write 1 here? I was supposed to write a half. Hey, I'm just looking at my picture and I'm like, that doesn't make sense. Did someone say in the chat? I didn't even notice that. Sorry if someone did say. Yes, thank you, Pluto. Absolutely. All right, I did write it wrong. Now, guys, if you have an x plus 3, we actually need to think of the shift that's happening here, right? This x plus 3 is actually a shift of 3 to the left. A lot of people get confused with this. Remember, in your x bracket, the direction of the shift, sorry, that's off the screen. The direction of the shift is always opposite to the sign of the number in that bracket. So x plus 3 means that we're moving 3 units to the left. So I saw someone saying here, it's gone off of my screen now, but I saw someone saying that we must just change the x to an x plus 3. But that is not actually the case when we are talking about the shift of a graph, right? G of x, this new graph that they're talking about, is this graph shifted 3 units to the left, meaning that this x-intercept also is shifting 3 units to the left. So we actually have to minus 3. Right, we have to subtract 3 from that x value. Remember, they're just asking for the x coordinate. So the x value is going to be a half minus 3. That's what we have to do there. And that is actually going to be negative 2.5 or negative 5 over 2. You are more than welcome to write negative 2.5 or negative 2.5. That's also fine. Right, so that's actually quite a tricky question, guys, because I think a lot of people will just say, oh, I'm adding 3, right? I'm changing the x to an x plus 3. Actually, you could have done that if you took your equation here and instead of x, you wrote x plus 3 and then did the calculation again. That would have been a longer way of getting to the answer, but it would have gotten you the correct answer. That's absolutely fine. But you can also think of this as a shift of 3 to the left. Right, so every single point on this graph, including the asymptote, would have to shift 3 units to the left. Okay, let's look at what is, so we were not asked to find the coordinate of x. I'm not sure what you mean. All right, you can just clarify there. So if maybe you're asking, what if they didn't just ask for the x coordinate? Well, then it would just be negative 5 over 2 and 0, right? The coordinates of that point would be negative 5 over 2 and 0. It's still the x-intercept, so the y value would still be 0. I think that is maybe what you mean in your question. All right, 4.1.4, the next question. Sorry, you can't see the numbering system there. It's 4.1.4. The equation of an axis of symmetry of h is y equals x plus t. Determine the value of t. All right, now what they are telling us here is that we are meant to find the equation of the positive axis of symmetry. We know that a hyperbola has 2 axes of symmetry. It has one with a positive gradient that is kind of going to run like that. And then it has one with a negative gradient that is kind of going to run like that. That's not perfectly accurate, but you get the idea. Right? The positive one is y equals x plus t. That's what they're telling us. And this one would be y equals negative x plus something else, all right? Whatever other number, let's make it a c. Okay, it doesn't matter. They're asking us for this one. They are asking us for that equation. Now, I have a nice way of finding the equations of the axes of symmetry. Apparently, it's not a method that is very widely taught, but for me, it works really well. Some teachers do a whole thing where you must sub in a point, and then I think that is the point that you sub in, the point of intersection of the two asymptotes, which is absolutely fine. If it works for you, that's fine. But a method that I think I was just taught this method when I was at school, actually, is that you always take your denominator in the equation and then your q value. Simple as that. And that is then your equation. Y equals x plus 1. I don't know what you guys think about that method. So you just, for your positive one, you just use the denominator as it is, x minus 1, and the q value as it is. You don't change anything. So that would be the answer for this. So now, remember they're asking for the value of t. So we would say, therefore, t is equal to 1. Right? The other one, when determining, no, you don't have to. Right? They're just saying determine the value of t, and that is an absolutely fine method. If they had asked for the negative one, yeah, it is a cheat code, right? Yes, I'm getting to that now. If they'd asked for the negative one, you're going to change it slightly. They haven't asked that in this question, but I'm just going to show you. You would just do negative denominator, and then again with your q value. Easy as that. So for your positive one, you use your denominator and your q value, simplify. For the negative one, you use negative denominator plus your q value, and then you would simplify that. So we would get negative x, right? And then negative times negative 1 is positive 1 plus 2 would be plus 3. That would be your negative one. You were taught like that also. Okay, good. So it's not just me. So yeah, that is a cheat code. Yes, absolutely. But like I said, if you prefer the subbing in method, you can do that as well. I just find that this is quicker. Yes, this is only for hyperbola that you would be able to use this. This is from the November 2022 paper, so last year's final exam. All right, 4.1.5. Normally the last question in a test or exam is the most complicated. Sorry, not in a test or exam, in a question I mean. Zoom in so you can screenshot. You mean the whole thing like this, or other way around? Kathy, is that fine? Let me know when you're ready. The rest of you read through 4.1.5 so long. So they're asking us here to determine the values of x for which negative 2 is smaller than or equal to 1 over x minus 1. Now, again, we see this and we start panicking a little bit. I want us to think, what was the equation of the graph that we have? The fact that they haven't told us to use the graphs here actually means that we could use any method, right? If you wanted to solve this algebraically, you absolutely could. They didn't say in the wording, sorry, let me move that across. They didn't say in the wording here, use the graph to determine the values of x for which this. So guys, you actually could have solved this algebraically, right? The problem here though, is that we have an x in the denominator. If you do AP Maths, which is now called FS Maths, you will learn how to work with this. But guys, remember when we're working with an inequality, right? If you multiply by a positive number, the inequality stays the same. If you multiply by a negative number, it would change. Now, we can't multiply by something with an x in it because we don't know if it's positive or negative, right? So that is a problem. Again, if you do AP Maths, you learn a whole method there, which is very complicated. You use like a sine table and an and. So it is actually easier in this case to just use the graph. Now the problem is we don't have the graph of 1 over x minus 1. We do have the graph of 1 over x minus 1 plus 2. So I'm going to have to move this minus 2 over to that side so that I actually have the equation of the graph on the one side of the inequality. So we are going to do that quickly. We are going to move this minus 2 over. And when I move this minus 2 over, I'm going to have a 0, right? So I'm going to have 0 smaller than or equal to 1 over x minus 1 plus 2. Hello, Rory. Yes, sorry, I did actually see it. Thank you so much for notifying me. I haven't had a chance to check yet. I will check after this live. Okay, thank you. Sorry that I left it on unread so that I could go back to it, and I've just been so busy the past few days. I haven't been able to check, but yes, absolutely, I will go take a look. All right, now do we see, guys, what is this question asking us for? Where is this graph? Now, maybe we don't like when the 0 is on that side, so let's quickly flip the whole thing. It didn't change direction. The minus 2 became a plus 2, right? Because I'm adding 2 on both sides, basically, so that minus 2 can go away, but the sign is still the same. 1 plus 2x minus 2. So were you asking, can we cross multiply? Well, the problem here is because it's an inequality. If you multiply an inequality by a positive number, the sign would stay the same. But if you multiply by a negative number, you would have to change the sign. And because we would be multiplying by a variable, we don't know if it's positive or negative. It doesn't actually have a value. So we can't do that because we wouldn't know if we would have to change the sign or not. Because is it positive? Is it negative? Okay, so that's why we have to do it this way. That's the only way. Guys, I'm just going to flip this whole thing around. I think it's easier to read if the equation of the graph is on the right. Just look at what happens when I do that. Now the sign must change direction. Just see if you guys understand what's happening there. The whole inequality is flipping around. So the sign also has to flip around. If you read it from this side, the graph must be greater than or equal to 0. From this side, the graph must be greater than or equal to 0. Joshua, you can't cross multiply because it's an inequality. It's an inequality. Can you not make 2 a function and then cancel out the 1? No, I'm not sure what you mean. Can you not make 2 a function and then cancel out the 1? A fraction? No. So like this. I think you guys are trying to complicate it, to overcomplicate. You must just use the graph. If you don't switch them around, no, it's not wrong. It means the exact same thing. I'm just showing 2 ways of writing the same inequality. Let me maybe just take that away because people are getting confused. Okay, what is this saying? This is saying 0 smaller than or equal to, this is the equation of h of x, right? So what does this mean? H must be greater than 0. Remember, if you're looking at h, you're reading it in that direction. So h must be greater than 0. So h of x, if something is greater than 0, it's positive or equal to 0. That's what I'm looking for. My graph, now I have a lot of stuff written here. I'm just going to erase everything quickly so that we can look at this with fresh eyes. Let me take that away. We are looking for places on this graph. Yes, x is a variable. Yes, it doesn't have a value. Well, it has multiple values because we're looking at the whole graph. All right, so we are looking for values of x for which the graph is positive or equal to 0. All right, so let's look at this. Remember, for a graph to be positive, it has to be above the x-axis. We looked at that in the previous question. We wrote that down. For a graph to be positive, it has to have values above the x-axis. It has to be above the x-axis. All right, so we have a whole bunch of places here where it's above the x-axis. There we go, for that whole section there. That is above the x-axis. And even here, guys, that section there as well. Sorry, the highlighting is a bit difficult to do, but there we go. So basically, it's everything on this graph excluding this part and then also excluding the asymptote, right? The graph doesn't exist at the asymptote. So how would I express this? I erased this, but this was a half, right? This was the point half 0. So we're going to say this section is where x is smaller than or equal to a half. Why am I saying equal to? Because the question also said equal to 0. Okay, so we're going to say where x is smaller than or equal to a half, and then for this part, we're going to say this whole section is where x is greater than the x value of the, what's it called, the asymptote, where x is greater than 1. So x smaller than or equal to a half, or x greater than 1. I can't say x greater than or equal to 1, guys, because 1 is the asymptote, right? And the graph can't touch that asymptote, so x can't be equal to 1. So for this one, it's very important that we exclude that value. We exclude 1. This one has to be equal because here I'm not talking about the asymptote. I'm talking about this point where the graph is equal to 0. You have to exclude the asymptotes, absolutely, which is why I don't have an equal to symbol underneath that one. All right, so that is the answer there. We're going to say, and again, I'll write it in both notations, x smaller than or equal to a half, or x greater than 1. That would be inequality notation. Or if you want, let me quickly move this a little bit. If you want to write it in interval notation, you would say x is an element of negative infinity. Like we said before, infinity always has to have a round bracket. A half is going to have a square bracket because it can be equal to a half in this case. Or 1 now has a round bracket because it has to be greater than 1, not equal to, and then infinity. Why is it equal to a half? Because the question is saying h of x greater than or equal to 0, and at this point, a half, the function is equal to 0. Y is equal to 0. All right, yes, the lesson is being recorded. I'll post it to YouTube either later tonight or tomorrow morning. All right, that is it for this question. Let me check the time, 4:30. We still have about half an hour left. I'm just going to take a sip of water. My throat is getting quite sore from all this talking. How are we feeling so far, guys? Anything that you wanted to ask me about before we move on? Go back to the other page. Sure, there you go. You're very grateful. I'm glad. Mr. Nobody, yes, when you use, let me quickly see, just go back up. When you're using the smaller than with a line under it, you use the square brackets. Yes, but not when it comes to infinity. Okay, and also not when it comes to asymptotes. So that is an important distinction to make. Yes, it's the smaller than or equal to symbol, but in this case, because on the left, well, to the side of the graph, I've highlighted the graph here, it can't be equal to 1 here, right? Because it's an asymptote. So you must just be very careful. Don't just say it's always equal, it's always square brackets when that line is there. It depends. Okay, so for asymptotes, not, and also not for infinity. All right. Someone asked, are we going to do financial maths? Not today, but we can do some financial maths next week. How often do I go live? Oh, sorry, I'm yawning. It depends on my schedule. I will probably go live quite often next week because I know it's crunch time for you guys, but you're also writing. Hey, do you guys have afternoon papers? Let me know, because I obviously don't want to go live when no one can join. What I'll also do is I will Monday. Yeah, I will post some YouTube videos. I was planning on doing that this week, but the week kind of got away from me a little bit. Oh, wow. IAB Maths Paper 1 is on Monday. Sure. Okay. Good luck for that. That's very soon. Okay, let's quickly see. All right. I am going to equation of G only. Okay, so Dimple, you are asking for 4.1.3. If you were asked to write the equation of G, then you would simply, in the equation of H, you would replace it with x plus 3. So you would do, let me do that quickly, that's a good question. If you were asked to write the equation of G, where G is h of x plus 3, you would take h, and in the place of x, you're going to have an x plus 3. And then you would have to simplify that afterwards, right? So in the place of x, you put x plus 3 because of that there. All right, so that is then actually going to be 1 over x plus 2 plus 2. All right, is that what you were asking? I'll just have some more water. Okay. I want us to look at maybe not the next question, maybe, oh, you see, I actually left space to answer and then I answered on the page. I want us quickly to look at this question here, which was the inverse question. Yes, absolutely. Yes. So someone's saying here that also gives us negative 5 over 2. Yeah, I did say that. You can find the equation and then make y equal to 0 and then solve for x from there. Exponential. I don't actually have an exponential question here. I wanted to look at this one quickly. Oh, the inequality is wrong every time. Then rather just use interval notation. Okay, then don't, or do you mean the questions? You're just going to have to practice. Guys, something that I can suggest, my matrics don't like it at all for some reason, but Siyavula. I don't know if you guys are aware of Siyavula. You can sign up for free, absolutely for free, and you can go on there. You can use it for maths and for physics. You can go to grade 12 maths and you can go to functions and you can search for inequalities and you can practice questions there. 4.2. Yeah, this one, but I don't want to do this one now. This is not a particularly, it's not a question that is only based on exponential graphs. I quickly want to go through this one. Okay, we only have just under half an hour, so I do want to talk about inverses quickly, and especially this one that has an area question in. I want to quickly go to that one. Yes, 5.5. Thank you. Yes, that's exactly why I want to do this one. Now guys, this one was quite unusual, the way that they asked this. I was surprised when I saw this question. I was actually saying to my matrix yesterday that I think they are moving away from only testing inverses with exponential graphs. I think they're moving towards testing inverses with other graphs as well. For many years, it was always exponential graphs. Last year, it was a straight line graph. And I think why they're doing that is because it does allow them to mix other topics in. So like you'll see here, they've actually mixed in length of AB and area of a triangle. So guys, I don't want you to think that in a paper 1 exam, you are only going to be asked to do paper 1 things. They are more frequently now mixing in some paper 2 content into paper 1 exams. So I think yesterday I was doing a 2021 paper with my matrix. We saw it in that paper. Here it's coming up in this paper again. So you have to, try to not be too thrown off by that. Okay. So let's quickly look at this. This is again from November 2022. For question 5, they're saying the graphs of G, which is this graph over here, is 2x plus 6. Now, I see already that someone says the y coordinate is 6. Absolutely. This is a straight line equation. Remember that your C value, your constant term, is the y-intercept. On the graph, we can see that point B is the y-intercept. So the coordinates there is 0, 6, and that is actually also the first question, right? 5.1, write down the y coordinate of B. The y coordinate is 6. All right, there we have our first answer already. Now, I just quickly want to read through the rest of this information. They're also saying that they've given us G to the negative 1, which is the inverse of G, right? So this line and that line is the inverse. Now, guys, we are supposed to know that if the y-intercept of the straight line is 6, that means that the x-intercept of the inverse is also going to be 6. So there we actually already have the coordinates of C as well. If we find D, then we could again just swap the coordinates to get that point there. The x-intercept of the straight line will be the y-intercept of the inverse. They haven't labeled this y-intercept, so I don't think they're going to ask us about it, but they might. Then we have a point of intersection here of the two lines. We are probably going to have to find that. Yes, the coordinates of A. All right, let's read through. We've already done the first question. The other things that they're saying here, just D and B are the x and y intercepts respectively of G. We can see that. We've already written that down or kind of looked at that. We have that C is the x-intercept. We have that there. The graphs of G and the inverse intersect at A. We know that. Okay, it's a good idea, guys. Always just read through everything that they've given here. Sometimes they write something up here that's not actually visible on the picture, which is quite mean of them, but they might do that. Okay, so please, please, please read through all of this before you just jump into the questions. All right, for 5.2, they are now asking us to determine the equation of the inverse in the form g to the negative 1x is mx plus n. Now, the inverse of a straight line is clearly also another straight line, okay? Now, guys, you have different things that you can do here. I suggest that we go the quick route and we just swap x and y. Right? We know that if you have an inverse or if you have a straight line or any graph, to get the equation of the inverse, you must swap x and y and then make y the subject. So g of x, I'm going to do it here on the side. The original graph is y equals 2x plus 6. That means that the inverse is going to be x equals 2y plus 6. Right? Now all that's left for us to do is to make y the subject. So I need to move that 6 over to the other side. So x minus 6 is equal to 2y. And now I'm going to have to divide by 2. Now x, instead of writing x over 2, I'm actually going to write a half x. I just prefer writing it in that way. But you can write x over 2. That's also perfectly fine. It is correct. And what is negative 6 divided by 2? Negative 3. All right, so that is the equation. Guys, we need to follow the instructions that were given. They want us to write it in this form. So we have to please say g to the negative 1x is equal to a half x minus 3. Right, there we go. That is the equation of the inverse. 2 marks. They usually give a mark for swapping and then a mark for the final answer. So if you want to skip some of these steps, if you're able to do that working in your head, that's also perfectly fine. You won't get actual marks for showing those calculation steps there. All right, so far so good. Determine the coordinates of A. Now A is the point of intersection of the two lines, right? So you actually have multiple options here. Guys, I also want to point out, I don't know if you remember this, the two functions that you have, right? If you have a function and its inverse, those two functions or graphs, it's not always functions, but those two graphs will always intersect on the line y equals x. Remember, an inverse is a reflection in this line. So if we have AB here, which is the original graph, if you reflect that line in y equals x, that will give you the inverse, right? That is kind of how inverses are introduced when you start working with them for the first time. I think that's how I always introduce them. So yes, absolutely, you can equate the two lines, which is easy enough to do. These are easy equations to work with. So you can say 2x, oh, my pen is giving up, 2x plus 6 equals a half x minus 3, and you can then solve for x. But something that is even easier, guys, that's why I told you to remember that they intersect on y equals x. Oh, someone is trying to phone me. I hope my network doesn't fail now. All right, so the reason why I was saying that these two lines intersect on y equals x, it's actually also a point of intersection of AB and the line y equals x. So you can actually do an even easier calculation. You can make 2x plus 6 equal to x. Yeah, it was my network. Sorry. Am I back, guys? Someone was phoning me. Hey, network. Okay. I'm just gonna give it a second. Oh no, I can see your comments. Hello, am I there? Can you hear me? Not. Am I back? Hello, I'm here, I'm here. Can you guys hear me? It's lagging. Oh dear. No, it's not gonna end. I'm still here. Sorry, someone called me and I think that messed with the network. Guys, don't leave. I'm still here. Tell me if you can see me. No, I'm not explaining. I can see your comments. Okay, I'm gonna start again. Yo, how irritating. Were you still on now? Were you still on? The live? Oh. Okay, no, that's fine. An 081 number phoned me and then everything shut down. Hello, I'm back. Sorry. Let's just wait for people to join again. Hello. Sorry, guys. Sorry about that. Someone tried to phone me, an 081 number, a spam number. It was probably Telkom or someone trying to phone me, and then it messed with my network. I could see all your comments, but I don't think you guys could hear me. So sorry about that. Okay, I'm gonna jump straight in. All of this will be in the recording, so I'm hoping that people that were here are not gonna miss out now. Welcome back, guys. So sorry about that. Okay, so what I was saying, I'm not sure when you guys lost me, but what I was saying is absolutely you can equate the two lines and solve for x. That's going to be quite an easy calculation to do, so you can do that. What you can also do is you can remember that two functions, a function and its inverse, will always intersect on the line y equals x. So instead of doing the point of intersection of your two lines, you can actually do the point of intersection of your function and y equals x. So you can actually do this calculation, which is a much easier calculation to do because you just have an x on that side, right? So I can just move the x to this side, x equals, and then that's 6 over to the other side, -6. Look at how easy that is, right? So you are actually able to do that as well. So remember, I'm going to make a little note here. Function and its inverse intersect on y equals x. 5.3. Yeah, so 5.3, they're asking for A, which is the point of intersection of the two lines. So you can do this calculation. Sorry, I just drew a line through the equation. You can do this calculation. You can equate the two equations because we have the equation of the function and the equation of the inverse. Or if you remember that a function and its inverse intersect on y equals x, you can actually equate one of your two equations. You could work with either one. I'm working with 2x plus 6 because that's the easiest one. So 2x plus 6 you can equate to y equals x. So 2x plus 6 equal to x. That's just a much easier way of getting to that x value. Yes, you can. You can always calculate it like that if there's an intersection. Sometimes a graph or a function and its inverse won't intersect, but if they do intersect, it will always be on y equals x. So you can always take one of the two equations and make it equal to x. That's another cheat code for you guys. Much easier to work it out in that way. If you wanted to work it out in the first way, that's absolutely fine, but you would have to multiply through by 2 and move across and. It would be a few more steps, not many more, but can you guys think if it was what's it called? Yes, I'm going to get to that. I have the x value. If it was a more complicated graph, so if it was like a parabola or an exponential graph or hyperbola, it's easier, instead of making two exponential graph equations equal to each other and solving for x, it's easier to make one graph equation equal to x because of y equals x and then solving. Now guys, that is the x value, right? X is negative 6. To get the y value, you could just sub it into one of your two equations. But guys, this point is on y equals x, right? Y equals x, that is the line. So the y value is equal to the x value. So if x is negative 6, y is also going to be negative 6. Sorry, my pen is telling me that it's been a long day. Or you can just sub it into that equation or y equals x. Any one of the three equations of any one of these three lines, you will get the y value. Right, so the coordinates of A are negative 6, negative 6. Okay, next question. Calculate the length of AB. Guys, we know how to do that, right? The length of AB, distance formula. All right, so AB is going to be equal to, and this is what I was talking about. This is a paper 2 question, right? But it's in paper 1. And the problem here is we need to actually use our answer for AB in the next question. So it is very important that you just have kind of a basic knowledge of your paper 2 content when you're going into your paper 1. All right, so what are the coordinates that I have? I have A and then I have B, which was the point 0.06. I must find the distance there. So I'm going to say negative 6 minus 0 squared plus, so I'm doing x minus x, and I must do y minus y. Negative 6 minus 6 squared, and the square root of that, you would type that into your calculator or work it out in your head if you want to. And the answer is 6 root 5. I'm just going through this very quickly because I want to get to 5.5. All right, so that is 6 root 5. That is the length of AB. I'm going to fill it in on my picture here. 6 root 5. That is the length of AB. Now, guys, in the next question, that's actually why I wanted to get to this full question so that we could do 5.5. They're asking us to calculate the area of triangle ABC. Now, triangle ABC is not drawn in here, but we can draw it in. So there's a lot happening here. I actually just want to clean this up a little bit. So let me just do that. Let's take this highlighted bit out first. I want to actually highlight everything. I'm going to take that away. Or we can take that away as well. We are working with triangle ABC. I'm going to connect B and C so that we actually see what that, oh, that's a curved line, so that we actually see what that triangle looks like. Okay, and now I'm just going to highlight that triangle. All right, there we go. Now, guys, there is a trick to this question. And you are going to be, I think, surprised when I show you the fastest way of doing this question. This is a function, right? We have g, and then we have the inverse of g. So AB, we just calculated in the previous question, was 6 root 5. AC is also 6 root 5. Because this is a function and it's inverse. Because of symmetry, right? This length will be the same as that length. Remember that a function and its inverse are always symmetrical about the line y equals x. I'm not going to draw it in now again, right? But I did it for the previous few questions. You know that it is symmetrical. Now, guys, this is an isosceles triangle. I don't know if you remember, right, that, and this is maybe something that you did in grade 8, possibly in grade 9. If you have an isosceles triangle, you can construct a perpendicular height in that triangle. This is going to blow your mind. And the perpendicular height, oops, let me put that back there, is always going to bisect your base. So if I know what the length of BC is, then I can say what that length is there, right? We actually don't need that, but oh, we're going to need it. Remember, what is the formula? Sorry, I just had to get my mind clear quickly. The formula for the area of a triangle, it doesn't have to be a perpendicular or a right angle triangle. You can always use this formula, half base times perpendicular height, if you have the perpendicular height. So what I've done here is I have constructed a perpendicular height, which I can do, right? Yes, I've constructed a perpendicular height. And guys, I'm going to use Pythagoras to work this out. I have 6 root 5. I have 6 root 5 there. If it's an isosceles triangle, a perpendicular height will cut the base in half. So let's quickly work out what BC is. I'm going to do the calculation here at the bottom. I have the coordinates of B. I erased it, but it was 0, 6. And the coordinates of C was 6, 0. Okay, so I had those two coordinates already. So BC, I'm going to work that out really quickly. The square root of, I'm going to do x minus x plus y minus y. Right, so that length there, the length of BC is actually, let me quickly see, 6 root 2. Right, so you would have to calculate BC. So this whole length is 6 root 2, meaning that this section is going to be half, 3 root 2. And this section is also going to be half, 3 root 2. So I can use that with Pythagoras to calculate the perpendicular height. How nice is that? So you're asking B, if we construct a perpendicular height, will it always bisect the base? Only if it's an isosceles triangle, which is what we have in this case. Because it's a function and it's inverse, that makes it an isosceles triangle. So asking here, is it possible to use any side as the base? In this case, we couldn't. You would have to use the side that's not equal to the other two, right? So that it's an isosceles triangle. So the perpendicular height has to come from in between the two equal sides. Okay, I'm quickly going to work out what this height is. I'm going to use Pythagoras to calculate this height. So I'm going to say h squared is equal to hypotenuse squared minus that side squared. Sorry, I don't know what's going on with this pen. Reason, Pythagoras. I think the battery on my pen is maybe running out. Yes, I see probability, thank you. So h is going to be 9 root 2 units. Okay, so now we are going to use that to find our area of the triangle. Using our half base times perpendicular height, it's going to be a half. The base was 6 root 2, that's BC that we calculated, and the perpendicular height is 9 root 2. So the answer is, if we work that out, it is going to be 54 units squared. Guys, this is not the only way in which you could calculate this. You can do other calculations. You could possibly use area rule if you work with angle of inclination of this line and angle of inclination of that line, and use that to calculate that angle. You can use area rule. Ma'am, could you also make 2 triangles? Yes, and then calculate DC as the base and 6 as height. Absolutely, yes. Who was that? Connor. Yes, that would also work. So you could work with this triangle here. That's another method that you could use. That triangle there. The base would be from, well, you would need to calculate that to 6, whatever D is to 6. You could use that as the base. And then the perpendicular height there would be 6, absolutely. And then for the bottom triangle, you would have the same base, because it would again be from D to 6, and then this A is -6, -6. Remember we calculated those coordinates. So the perpendicular height here from DC to A would also be 6. Yes, absolutely. And then, oh, Pluto, let me quickly see. I missed your first. Can you use the midpoint formula for BC? Midpoint formula for BC, then calculate the height by using distance formula. So I did get the height, hey, it's 6 root 2. I did that calculation there. And then use Pythag to find the base for each side of the triangle. I'm not sure what you mean, but I'm sure it could work. There are other ways of doing it. I just wanted to remind you guys that this was also an option. All right, that if you have an isosceles triangle, you can construct a perpendicular height. So yeah, there are other ways. Can we use half a, yeah, so you can use area rule. That's what I was talking about earlier. You can say half 6 root 5 times 6 root 5 times sine of angle A, but you would first have to calculate this angle, right, which is going to take quite a long time. You must use angle of inclination with that gradient, angle of inclination with that gradient, and then you can get that angle. But that will also work. Guys, for these questions, whatever you see, all right, don't necessarily try and find the shortest route. If you find a way to find the area that's going to work, then use that. That's absolutely fine. All right, I saw your millions of comments asking for probability. Point taken. Guys, there are lots of probability videos on my YouTube. So on the weekend, go take a look. I have lots of specifically counting principle videos as well, but yes, we can do that next week. B, I think you asked me this before. When you construct the perpendicular height, it will only bisect the base if it is an isosceles triangle like we have here, because this side is equal to that side. So then the perpendicular height will bisect the base. If these two lengths were different, then it wouldn't. Okay, I hope that answers your question. Measurements, total surface area and volume. What grade are you in? That's not really... Still, we can't understand. We want to see you solving. Hope, I'm not sure what you're talking about. Is that probability? Grade 10 algebra, yes. I will do some other grade. I will go live for other grades once the matrics are done with their papers. More of determining area, yeah, sure, that will also come up in analytical a lot. The name of my channel on YouTube is also Miss Hanekom. Lovely, I'm sorry, I have to go now, guys. Unfortunately, I have to go fetch my little girl from daycare now. She's still there and it's already 5 o'clock. Why am I only focusing on the grade 12s? Because it's their final exam ever, and they write way before most other grades. So we're going to do grade 12 first, and then I'll do the other grades after that. Your time will come. Yes, when you are in grade 12, you will also be happy that I am focusing on you first. My next live, I'm not sure, guys. Why don't you go to my Instagram and go comment on my latest post when you want me to go live again. Okay. Thank you, Sue Bartley. You are welcome. I like helping you guys. Nature of Roots, yes, I can talk. I'll see what I can do. Okay, thank you guys. Sorry, I gotta go. Thank you so much for being here and for interacting and for asking questions and for making suggestions. It's also other grades finals, be fair, please. Yeah, but other grades aren't applying to university. All right, thank you guys. See you next time. Have a lovely weekend. Here's again with fundamental counting principle. I know. I'll get there. Thank you. Bye. Be fair, please. Get lost.
Beefing about time schedules and stuff. How do you beef on that?
I'm telling you, kids will beef on anything.
You just want beef.
Lekker, 83K. Okay, laat ek gaan piepie.
Yes, well done. So well done.
Yeah. Let's see, that was an hour and 45 minutes live. My battery is on 69%.
How do you feel?
I feel good.